Now let's make the same app using Bloc. After creating the myCounterBlock app using the Flutter create command from the command line, install the Equatable and Flutter Bloc package. Also, command include line of the analysis options.yaml file. It's a simple app, so let's start by making the skeleton of the app in advance. Let's start with main.dart. Title is myCounterBlock and hide the debug banner. I deleted my homepage, which was originally a stateful widget, and create a new one as a stateless widget. My homepage consists of a text widget and two floating action buttons. The text widget displays a 0 of font size 52.0, and the onPress callback of floating action buttons is an empty function. Next is otherPage.dart. The otherPage widget is a simple stateless widget that displays other in the middle of the screen with font size 52.0. First, we'll make a block. After creating the blocks folder under the lib folder, we'll create the templates using the block extension. Right-click on the blocks folder and select the block, new block from the displayed menu. A box will appear asking you to enter a name. I will type counter. Then a block folder is created under the blocks folder. And at the same time, three files, counterstate.dart, counterevent.dart, and counterblock.dart are created under the block folder. There is no need to change the name since we are only going to make one block at the moment. But if you were going to make multiple blocks, we need to make the name clear. I will rename the block folder to counter because the block I made is a block related to counter. When I made a new block using the block extension, there was one more file called counterevent.dart, unlike when I made a qubit. This is because, as I explained before, unlike qubit, block uses events to communicate with the UI. Qubit and block have different ways of handling state, but there is no reason why the state they handle should be different. Therefore, in the countstate.dart file, I will copy the contents of the counterstate.dart file created in the myCounterQubit app as it is. I declared a final variable counter of integer type and applied the generate constructor, generate equatable, generate toString, and generate copy of .data class generate extension. And I created a factory constructor called counterState.initial that will be used as the initial state of counterblock. This factory constructor returns an instance of counter state with counter value of 0. Next, it's time to create an event in the counterEvent.dart file. An abstract class called counterEvent has already been created. If you think about it, myCounterBlock app has two kinds of events: the event that occurs when the plus button is pressed and the event that occurs when the minus button is pressed. There is a naming convention for events in the block documentation, but I will not follow the convention and name events by adding the suffix event after all event names. The advantage of this is that even if the name in front of the event suffix is somewhat awkward, you can clearly tell if it is an event. Now let's call the event that increments the counter increment counter event and extend counter event. Similarly, the event that decrements the counter is called decrement counter event, and we will extend counter event. Finally, it's time to implement the counter block in the counterblock.dart file. If you look at the code that has already been created, a red squiggly line is displayed in the counter initial. That's obvious. That's because there is no class called counter initial. Instead, we'll replace it with a factory constructor we made for the initial state called counterState.initial. And if you look at the code, there are some differences from qubit. First, we extend the block, not qubit, and in qubit, only the state type was specified, but the event type is also specified in block. Second, a count event type on function with event and emit as argument is given. If you look at the signature of the on function, there is a future or void type handler function as a required argument. In other words, it is mandatory to define a future void or void type handler. This handler receives an event and a count state type emitter as arguments. And there is a transformer as an optional argument in the on function, and this transformer will be explained later. A caveat here is that emit should only be used within an event handler. In other words, a new state should be generated only as a result of an event. And if you read more, it is said that there should be only one handler for the e-type event. If there are multiple handlers for e-type event, state error is thrown. Now, let's implement the body of our own count event. First, count event is an abstract class, so the actual events are increment count event and decrement count event. So we will create two own functions. Modify the current count event to increment count event. Use the copy the function of the state in the body of the callback to create a new state whose counter value is state.counter plus 1 and then emit it. In the case of a decrement count event, we will create a separate event handler function underscore decrement counter to process event. Although the processing logic of underscore decrement counter is not complicated, if the processing logic is complicated, create a separate function like this to process it. The void type underscore decrement counter function receives an decrement counter event type event and an emit function that is an emitter of a counter state type as arguments. Use a copy the function of the state to create a new state whose counter value is state.counter minus 1 and then emits it. Now that we have completed implementing the block, it is time to implement the UI. The first thing we need to do is dependency injection, so that we can use it in widgets that needs counter block. Since the My Homepage widget requires a counter block, any parent widget or My Homepage is fine. I will wrap Material app with the block provider. Material app is wrapped with the block provider of counter block type, and in the correct callback, an instance of counter block is created. We are now ready to use counter block in the My Homepage widget. Whenever the state of 0 of the text widget changes, you need to update it. My counter qubit listens for state changes using block builder. But when I talked about the extension method of build context earlier, I said that context.watch type T listens for changes in type T object. So this time, we will replace 0 with state.counter of counter block instance accessed using context.watch. However, counter block doesn't show functions that can be called directly from the outside like counter block does. Instead, it provides a method called add that can add an event to the stream so that it can be called externally. The add method passes the instance of an event as an argument to the onEvent function of counter block. In the first floating action button, call the add method of counter block using the of_static method of block provider, and give increment counter event instance as the argument. In the second floating action button, the add method of counter block is called using the read extension method of build context, and a decrement counter event instance is given as an argument. Now all that's left is to display a dialog box when counter reaches 3 and move the other page when counter reaches -1. To do this, wrap the center widget with a block listener and replace the subject with a counter. Since the code in the listener is exactly the same as in my counter qubit, I will paste the code of my counter qubit. I ran the emulator for testing. 1, 2, 3, dialog is displayed. I went to 4 and then went to 3 again. Dialog is displayed again. When it becomes -1, it moved to other page. -2, then -1, then move to other page again. Next, let's see what to do if additional information is needed when calling qubit's public method or adding an event to the block.